Okay, so today we're going to talk about how to solve equations and inequalities, and we're going to overview some of the most important types of equations and inequalities. You should have learned this in Algebra 1 and Algebra 2, so these day 1, day 2, and day 3 notes should be very much a review. So the type of solutions could be real, and that would occur when your discriminant is greater than 0. You would get two distinct real solutions. If your discriminant is equal to 0, then you're going to get exactly one real solution, and we call that a double root because the same number appears twice as your answer. And then the last type of solution would be an unreal solution, and we call that imaginary, and those always come in pairs, so that would be two imaginaries. And if you think about it, it's because you're taking the square root of that number. So if you take the square root of a positive number, you get a real answer. If you take the square root of 0, you just get 0. So you'd have negative b plus or minus 0 over 2a. And if you take the square root of a negative number, then you would get an imaginary. All right, moving on to the first example, we're going to solve this first one in two different ways. We're going to solve it using the quadratic formula and then also using completing the square. So if I want to do it with quadratic formula, I do need to move all my terms to one side. So I'm going to move the 1 to the other side by adding 1. And then when I look at a, b, and c, a is equal to 1, b is equal to 4, and c is equal to 1. So remember, if you don't see a number in front of a variable, that's a 1, not a 0. And then if there's any negative signs associated with the coefficient of any terms, then make sure you include the negative sign as part of your a, b, and c as well. So if we're going to find negative b, it would be negative 4 plus or minus the square root of 4 squared minus 4 times a times c, all over 2 times a. And then we're going to simplify. So 4 squared is 16. 16 minus 4 is 12. So we have the square root of 12 over 2. And then because 12 could be written as 4 times 3, we'll look at that as square root of 4 and square root of 3. So that would really become 2 root 3. So it's negative 4 plus or minus 2 root 3 over 2. And then as a final way to simplify, you can reduce the 4, the 2, and the 2, and you can divide those all by 2, which makes your final solution negative 2 plus or minus 1 root 3. So we're just going to say root 3, and we don't need to say divide by 1. So this would be your final solution. All right, now we're going to solve it using a different method. So completing the square, we actually want to keep the 1 where it is, and we're going to leave a little space on purpose there, and we're going to create a little box. So I'm going to add a value to that, and whatever I add there, I'm also going to add over here. But it's not just going to be any number. It's going to be half of the middle term. So my middle term is 4. I'm going to do half of that, so that's 2. And then I'm going to square it. So 2 squared is 4. Now to keep your equation balanced, whatever you add to the left side, you also have to add to the right side. So why would I want to complete the square? Well, now this is factorable as what can multiply to 4 that adds to 4, which would be 2 and 2. And you'll notice that you get the same binomial twice. So this becomes x plus 2 quantity squared on the left side. On the right side, negative 1 plus 4 is 3. And then from here, I'm just going to solve for x by isolating it. So if I undo the square, I would take the square root of both sides. And if I were to take the square root of both sides, I need to say plus or minus root 3. And the square and the square root cancel, so I just have x plus 2. And then my last step is to subtract 2 from both sides. So I get negative 2 plus or minus square root of 3. So as you can see, you get the same solution that we got when we solved it using the quadratic formula. So if the problem just says solve, find all the real roots, find the zeros, the x-intercepts, whatever it says, and it doesn't say the method that you use, then you can use any method. Okay, so for part B, we're going to use a graphing utility, which is basically just use a graphing calculator. You could use Desmos or some other online graphing calculator, but we'll use the graphing calculator to do the same problem as before. So the main thing that we need to do is we need to go to y equals, and we need to type in our equation. So our original equation was x squared plus 4x plus 1. Now notice I'm plugging in the version where it's equal to 0. So I'm going to put this in my calculator. And I'm going to hit zoom 6, and that graph's on my standard window, and you can see that that's your graph. So if I look at the approximation, it looks like there's an x-intercept in between 0 and -1, so somewhere over here. It looks like I have another 0 somewhere between -3 and -4. And it looks like my vertex is somewhere around -2, -3. So I'm just going to approximate that, and there's your graph. We could get a more accurate picture of where our points are if we go to second and graph and look at our table of values, so you could plot some other points. But I just wanted to focus really on the x-intercepts. So if you look at your x-intercepts, that's what we're going to try to confirm, that they are actually -2 plus square root of 3. So a couple ways you could do this is once we have our graph, so as a reminder, zoom 6 is a good way to get a standard window. If I just hit trace once, I can type in any value that I want to confirm that it's a solution. So I think one of the solutions is -2 plus the square root of 3. And then if I hit enter, it does show me that -2 plus square root of 3 really is a point on my parabola. It's that number, comma 0. And I can also test the other version, -2 minus square root of 3, and see if I hit enter, if that's also a solution or an x-intercept. And it is. All right, so that's one method of checking. The other method of checking is you could just go to second trace. Let's say I had no idea what my 0 was, and I'm going to choose the 0 option. And that's number 2. And then you have to tell it any left boundaries or right boundaries. So it says left bound. My cursor is blinking near the one further to the left. So if I move to the left a little bit, I'm somewhere to the left, and I hit enter. And you'll notice it draws this little boundary line. So I'm going to move now to the right, and I'm going to go past the x-axis so that I'm below the x-intercept, and then I'm going to hit enter. And then now you see another boundary line to the right, and then hit enter one more time. You don't even have to make a guess. And then it gives you the decimal approximation for that 0. So basically you set a left boundary and a right boundary. And you say that my 0 is somewhere in between those two boundary lines, and then it'll give you the decimal approximation. So as a decimal, it's approximately -3.732. I would say 3 decimal places is pretty standard for this class. And if I want to do the other one, I'd hit second trace, choose the 0, which is number 2. When I do my second one, make sure you go to the other side of your graph, hit enter. Notice that my left boundary is, my cursor is below the x-axis, and see where the vertical line is. It's to the left of where my x-intercept is, and then I'll move anywhere to the right, hit enter, and as long as my 0 is in between those two vertical lines, then I'm good. Hit enter one more time, and you can see that your other 0 is at -0.267, but then I have to round up, so that would be 268. And if you were unsure what -2 plus square root of 3 is, you can go back to your main screen and see what that is, and -2 minus square root of 3. And then those match up with the ones that we found with the estimates. Okay, so now we're finally done with this problem. And now we're going to move on to a new problem. It says, determine how many real roots the following equation has. So we just care about how many. We don't actually care about what the roots are. And so when you see that, that means to focus on the discriminant. So remember, the discriminant is the b squared minus 4ac part, and we're going to decide if that b squared minus 4ac is either positive or negative or 0. So we've got a is 1, b is square root of 3, c is 3/4. So if I do b squared, I've got square root of 3 squared minus 4 times 1 times 3/4. And I just need to simplify this. So square root of 3 squared is 3. 4 times 1 times 3 would be 12. Divided by 4 would be 3. The easier way to do that is to cancel out the 4 and the 4. And you're just left with 3 times 1, which is 3. So 3 minus 3 is equal to 0. All right, so that tells me my discriminant. And that's not telling me that I have a solution at 0. It just tells me that the value of the discriminant is 0. That tells me that there is one real root. It's actually a double root. And that's something where the vertex would be on the x-axis, and you have the vertex counting as 2 solutions. All right, number 3 is a solve the absolute value equation. So we need to remember the definition of an absolute value, which is a distance from 0, and we should know that distances are always positive or 0. You can't have a negative distance. So if we keep that in mind, we know that the quantity that's inside of the absolute value could either be positive 25, or that value, 6x minus 5, could be negative 25. Because if we took the absolute value of 25, we'd get 25. And if we took the absolute value of negative 25, we would also get 25. So these are our two situations. Either the inside of the absolute value is positive or negative, but in any case, it turns into a positive 25. So from here, we're just going to solve the equation. So we're going to add 5 to both sides. That gives me 30. And then I'm going to divide by 6, and that's going to give me 5. And then over here, we're also going to add 5 to both sides. It's going to give me negative 20. And then if I divide by 6, I get negative 20 over 6, which is the same as negative 10 over 3. So these are your two solutions to your absolute value equation. All right, now we've got a couple of inequalities. So the first one is a pretty standard inequality where we have to distribute. So we could distribute first. Don't do 3 minus 2 because order of operations says you have to multiply before you subtract. So we're going to bring the 3 down, but then we're going to do negative 2 times 5, which is negative 10x, and negative 2 times 7, which is negative 14, and it's less than 21. So I'm going to combine my like terms. My like terms would be 3 and negative 14. So we've got negative 10x minus 11 is less than 21. And then if I were to add 11 to both sides, I've got negative 10x is less than 32. And if I divide by negative 10, you divide or multiply by a negative number, you have to flip the sign. So when we do this, my answer is going to be x is greater than negative 32 over 10, which could be reduced. So if I divide by 2, I would get negative 16 over 5. So x is greater than negative 16 over 5. Now, sometimes we are asked to express our answer on a number line. If we were to do that, let's say 0 is here, negative 16 over 5 is somewhere in the negative zone. You would use an open circle and you would shade to the right. But that's more of an algebra 1 way to express your answer. So instead, for this class, we typically will do an interval notation. And interval notation says we go from negative 16/5 all the way to infinity. And we don't include negative 16/5, so we have a parentheses for that one. And infinity is not a specific number, so we include parentheses on the other side as well. So I would say that this is probably the best way to write your solution. So on number 5, since we have a left side, a middle side, and a right side, our goal is to isolate the t on the inside. And to do that, we're going to undo anything around it. So I would suggest that we multiply by something that will cancel out all of our denominators. So 3, 2, and 4 all go into 12. So I'm going to multiply by 12. But since one of them is a negative, let's just multiply by negative 12. All right, so when I multiply by a negative, remember you're going to flip your signs. So your signs are going to become greater than or equal to. And then I have to do 2/3 times negative 12. So that's going to give me negative 24 divided by 3, which is negative 8. And then I'm going to still have the 5 minus 3 over 2. However, it's going to be multiplied by 6 this time because negative 12 divided by negative 2 is 6. And then 3 times negative 12 is negative 36. Divide by 4 is negative 9. And I'm going to distribute the 6 instead of dividing by 6. That way I don't have to deal with fractions until the very end. So I've got negative 8 is greater than or equal to 30 minus 18t, which is greater than or equal to negative 9. And then I'm going to subtract 30. So this gives me negative 38 is greater than or equal to negative 18t. And subtracting 30 from the negative 9, I get negative 39. And then my last step is to divide by negative 18. So since I'm dividing by negative, again, I'm going to flip my signs. And I just need to reduce. The middle is just t, but 38 and 18 are both divisible by 2, so that'd be 19 over 9. It's positive now. And 39 and 18 are divisible by 3, so that'd be 13 and 6. All right, so there's my final answer with inequality symbols. If we were to do this on a number line, I would have 19 over 9 and 13 over 6, and I'd have closed circles this time, and I'd be shading on the inside. But since we're trying to deal with interval notation, I'm going to do 19 over 9, comma, 13 over 6. And I'm going to include brackets this time because I do have closed circles and I do have a point actually at 19 over 9 and an actual point at 13 over 6. Last problem is number 6. So it says, for what kind of values of k would kx squared plus 2x plus 7 equals 0 have 0 real roots? So no real roots means that there would be 2 imaginary roots. So the fundamental theorem of algebra says that if you've got a standard polynomial, like a quadratic equation that has 2 degrees, I have to have exactly 2 roots. They might be real, they might be imaginary, it might be the same number twice, so it might be a double root, but I definitely have to have 2 solutions in some capacity. If I have 2 imaginaries, that means that my discriminant has to equal a negative number, because that means I'd be taking the square root of a negative, right? So reminder of what is the discriminant formula. It's b squared minus 4ac. So a is equal to k, b is equal to 2, and c is equal to 7. So we're going to use those values in our formula. So 2 squared minus 4 times k times 7 has to be negative. Well, how do I say that something is negative? If something is negative, it's less than 0, which means that this inequality, 2 squared minus 4k7 times 7, has to be less than 0. So now I'm just going to solve for k. So only unknown, so I have 4 minus 28k is less than 0. I'm going to subtract 4 from both sides, and I get negative 4. I'm going to divide by negative 28, and when I divide by negative, that makes my symbol flip, so it's k is greater than, and I just need to divide, so the negatives cancel, and that reduces to 1 over 7. So k has to be greater than 1/7. But again, if I want to do it on a number line, I would say here's 1/7. I would have an open circle and then shade to the right. But in interval notation, it would be going from 1/7 to infinity. So both of those should have parentheses, not brackets. All right, that's all for these notes. So if you have any questions, ask your teacher.